Okay, these are the Algebra POWs 25 through 32. On number 25, the answer should have been D. There was two ways you could go about it. You could use the calculator, and for the calculator, you would go to list, and you're going to put in your values for your X and your Y. You're going to go back to list, scooch over to calc, and then you're going to go down to the 0 one and pick exponential regression. Hit that twice, and when you do that, up's going to come your equation. Y equals a times b to the x, and then it will tell you what a is, and then it will let you know what b is. And remember, b is your common ratio. And when you do that, you're going to see that it matches D. But if you forgot how to put it in the calculator and you need to do it by hand, you can find the common ratio just by dividing the y's. And when you do that, I did a couple of them. I did 5.04 divided by 6, and that got me 0.84. And then I went down and did the next two just to make sure the ratio was similar. So I did 4.23 divided by 5.4 and got that really long number right there, which when rounded would round to 0.84. So, well, when looking at their choices, their growth rate was only one place past their growth rate was it only went out to the 10th digit, so I just rounded it to 0.8. So once you have that, in order to find the initial value when x is 0, all you need to do is divide the very first y that you had, which was 6, divide that by, I went a little further than the 0.84, I went 0.8392, and I got 7.149666,349, which when rounded, that just rounded to 7.1. So then this time the A was 7.1 and the R was 0.8, which matched D. Okay, number 26. Number 26 was an investment problem with interest rate. And when you're creating your equations, you need to remember that X is representing the time, and time is in years. Well, this time they were asking about 18 months, so you had to convert 18 months to time, which is 1.5 years. So they already provided the equation. The only thing they didn't provide you with was the time, the X. So once you converted that to 1.5, you just plugged it into the equation, the f of x equation. So we did 6,500 times the quantity of 1.045, because that was the annual interest rate. And after 1.5 years, you will end up with $6,943.65, which was B. Okay, number 27. This one, they started off with a square, and they decided to lengthen each side by 8 inches. So the answer on this one was D. And what I did is I drew the old square, and whenever you're finding the area of a square, you just do side squared, so that would have just been x squared. And the new one, they wanted to increase the side by 8, so that one was x plus 8 squared. I did this one the long way. So I took 8 plus x, when I'm writing the squared there, I wrote out what it really meant. That meant x plus 8 times x plus 8. And right here, then I distributed, also called foiling. So I did x times x, which got me x squared, then 8x. Now it's this one's turn, another 8x, and then 64. Right in here, I combined like terms. And so that's how I got x squared plus 16x plus 64. Another way you could have remembered it, whenever you are squaring a square, you could remember square, double the middle one, and square. So that could have been x squared. If I'm doubling this, 8 plus 8 is 16x. and square it again, and you get 64. Okay, number 28. Number 28, it wanted you to find the perimeter when given the length and width of a rectangle. So I wrote down, that answer was C. And then to solve that, I wrote down the perimeter formula, which is 2 times the length plus 2 times the W. And what I did was I just substituted in the length that they said was 3x minus 2, and they said that the width was x squared minus 4x plus 8. So I substituted those values in, and after I did that, I distributed. So when I distributed, I got 6x minus 4 plus 2x squared minus 8x and plus 16. Once I got to this line, I combined like terms. 6x and a negative 8x were alike, and then the negative 4 and the 16 were also alike. So when I went down to the next line, I put the equation in order from highest degree to lowest degree. So I started with my 2x squared minus 2x plus 12, and that answer matched C. Number 29. Number 29 was also talking about perimeter, but then in the end it was asking for an area formula, so I needed to create 2 equations. This answer was A. So I started with the perimeter formula, and they told me that the perimeter was 44. They didn't tell me the exact length or the exact width, so I just wrote 2L plus 2W equals 44. For the next equation, they did tell me that the length is going to be 6 feet longer than the width. So that's how I came up with the second equation. Once I did that, I needed to substitute this amount in for up here on this equation. So that's what I started doing. And right here I distributed. Got 2W plus 12 plus 2W plus 44. When I got down to the next line, I had combined like terms and came up with 4W plus 12 equals 44. I wanted to move the 12 to the other side with the 44, so I subtracted it from both sides. And that's how I ended up with 4W equals 32. Divide each side by 4, and W equals 8. We're only halfway done because we only found the width. So you take that and you put it back into either one of these equations. I'm all about putting it the easiest equation. So I substitute it back into this one. So I just wrote it over here. So L equals, here's where I'm substituting, 8 plus 6, which is 14. So the width is 8 and the length is 14. Still not done because it really asked for what the area would be. So the area formula is length times width. So I just multiplied 8 times 14 and came up with 112 feet squared. Number 30. Number 30 was giving you some information and it wanted you to turn it into an equation. So it's telling you that a cell phone plan costs $49 for 200 minutes. For each minute over 200, the customer is charged an additional 10 cents per minute. Which equation below could be used to calculate the monthly bill Y if a person talked X minutes over 200 a month. That's the key right there, the X minutes over 200. So in this one, the answer is A, because you have your constant amount that you're going to pay right there, which is $49. As long as you stay under 200 minutes, that's what you're going to pay. If you talk 5 minutes on the phone, or if you talk 200 minutes on the phone, you're going to pay $49. Every minute over that, you're going to pay 10 cents. And that 0.1 right there, the 10 cents, that's the rate of change, which means that's the additional amount that you're going to be charged for each minute over 200. Remember, X is representing the amount of the minutes over 200. You don't need to subtract that from 200. That's that would be D, but we don't want that. We just want this amount, trying to calculate what it would be if you went over the 200 minutes. Okay, number 31. This one is giving you another equation, or it's giving you some information, and it wants you to pick the correct equation for it. So it starts off telling you that there's an initial turtle population of 65, and each year it's going to increase by 5 turtles. And it says if X is the number of years after the initial observation, which equation best models the sea turtle population? Well, you need to pick A because A is a linear equation, and when the linear equations, I wrote down the linear equation model right here, and remember the linear equation is y equals mx plus b, and b is representing the initial amount, which is 65, which is what A has. As they said, when they started with 65 sea turtles. M is representing the rate of change. Well, they said that that's going to change by 5 turtles every year. They're going to increase in that amount. X is the time in years, and Y is just the total amount. Well, the only 2 equations up here that were linear equations were A and C. And C is incorrect because that would mean that they started off with 5 turtles, and every year after that they would have 65 more turtles. That's backwards of what it really wants. D is an exponential equation, and this is not growing exponentially. If something grows exponentially, it's multiplying, it's growing very quickly. This one was it was an arithmetic growth. So it was just adding 5 turtles every year. So that's why A was the correct answer. And number 32, it was talking about a high school tournament, and they needed to raise at least $1,500. And there was 2 separate kinds of tickets you could buy. You could buy student tickets for $3 or non-student tickets for $5. And the most that the gym could hold was 400 people. So it wanted to know which of these choices down here could represent the number of types of tickets sold and yet make the most amount of money and still not exceed the capacity that was going to be in the gym. Well, that answer was D. A and B, when you added the amount of tickets that they sold, they only sold 300 tickets. So there would be a lot of empty seats. So that's not going to get you the most money that you want to earn. On C, you can't have 150 students and 350 non-students in the gym because that's over capacity. That added up to 500. So D, that was the one that sold the most tickets and still was within the 400 seating capacity. And when they did that, they were able to raise $1,655. So what I did was I created an equation. Actually, I created an inequality. And S stood for student tickets, and N stood for non-student tickets. Student tickets went for $3, so I wrote 3S. Non-student tickets went for $5, so that's why that's 5N. So the amount of student tickets plus the amount of non-student tickets, we wanted that to be greater than or equal to $1,500 because we wanted to have at least that much money. That's how much we at least wanted to earn. So I went back up to D and I plugged in 170 for the number of student tickets and 229 for the number of non-student tickets. Multiplied that one by $3, multiplied this one by 5, and that's how I came up with how much they earned. So they earned $1,655, which was greater than the $1,500 that they were hoping for. So that's why D was the answer on this one.